All right, welcome back. We've made it to our last video here in the S1 equation series. In this video, we're going to tie in together everything we've learned in the previous videos and perform a practical example of computing our takeoff data. So in this scenario, we're going to take off at a GTR, Golden Triangle. Let's see, the runway or 18 or 36 doesn't matter. It's 8,000 feet long. The conditions are going to be 500 pressure altitude here, full weight, so 15,800 pounds. It'll be 30 degrees outside, and let's say it's in the summer and we just had a thunderstorm roll through or a shower, and the runway is in a wet condition. So how do we compute our takeoff data? Well, first, let's remember those concepts we learned. S1 must be less than or equal to the lowest of refusal speed, max braking speed, or rotation speed. However, it cannot be lower than the higher of critical engine failure speed or ground minimum control speed. Our runway required must be 6,000 feet or distance to reference zero, whichever is greater. And S1, if it equals to rotation speed, reference zero is calculated using takeoff ground run and takeoff flare distance. And if S1 does not equal rotation speed, reference zero is used by calculating critical field length plus takeoff flare distance. All right. So in our takeoff data, we need to know four things, and that's what we're going to use for our checklist when you're actually in the aircraft. We need to know our TRT setting. We need to know the AOA, which will always be 1.2 for takeoff. We need to know what S1 is, and we need to know what our climb out speed is. All right, so looking at our in-flight guide, if you're at Columbus, it'll be on page 69, and we'll look through the rows here for all of our information. If we go to the full weight, takeoff weight, and 30 degrees, well, we'll find our data. So TRT is going to be 98.2, and we say that it's 98.2 because we can see that for this configuration, we need to be a 10-flap ACM off. And you can check the notes there to make sure that we're at 98.2. We already know our AOA is going to be 1.2. Now we need to determine VCO, our climb out speed, and S1. VCO is pretty easy. If we look to the far left, we'll see that VCO is equal to 123. And now the question remains, what is our commitment to takeoff? What is S1? So let's get all of our data. Rotation speed is equal to 114. Refusal speed for the wet runway is going to be 108. So for a wet runway at 8,000 feet in these conditions, refusal speed is going to be 108. Max braking is equal to 130 knots. And critical engine failure speed for a wet runway is going to be 77 knots. And VMCG, we know, is 88 knots. All right. Other data points we need to know. Takeoff ground run is going to be 2,986 feet, or for easy purposes, let's just call it 3,000 or 3.0. Takeoff flare distance is going to be about 1.6, and critical field length for our wet runway is going to be 4.8, or I guess it would round up. Let's be conservative and call that 4.9. Now, I need to determine my S1. So, knowing our equation down here and knowing that we're going to be very stop-oriented, we're going to choose the lowest of our three variables to the right, and that would be our refusal speed. So, S1 equals refusal speed, which is equal to 108 knots. But we know now that S1 also does not equal rotation speed. So are we done yet with our planning? Nope. We need to calculate our distance to reference zero and ensure that it occurs no later than the departure end. We've already satisfied that we have at least 6,000 feet, but we need to make sure our distance to reference zero is no greater than that runway length. And because we've already studied it and we know it, reference zero does not equal rotation, so we're going to use the second option here of using critical field length plus takeoff flare distance. So critical field length is 4.9 plus our takeoff flare distance is 1.6. And let me do some quick math. There's 1. That'll be 6,500 feet required for our takeoff, and in which case it's greater than 6,000 feet, so our distance to reference zero is now what drives our runway required. And the last thing is to compare our runway available to our runway required, and we have 6,500 feet available, and that is going to be less than 8,000. Or excuse me, we have 6,500 feet required, which is our distance to reference zero. And that is less than our 8,000 feet available. So for this takeoff in these conditions, we know that we can legally take off and that we are safe. And this video concludes our S1 equation series. Hope you enjoyed it, and pass it along to your friends.